Hello and welcome. This video is a short overview of some expanded capabilities you can expect to see in MACE 2020R1. It's slated for release here at the end of January, early February of 2021. Specifically, what we're going to go over today is the embedded Codescript editor, a powerful new feature that gives the MACE user the ability to create, compile, and run code scripts from inside of MACE itself. And we're going to illustrate the power of code scripts by overriding some of MACE's default artificial intelligence or engagement behavior to emulate a cooperative blinking tactic for two SA6s. And the cooperative blinking tactic is going to be triggered by a passive receiver, specifically a Kolchuga. The Kolchuga is going to listen for incoming RF energy, and when it judges that the threat is inside a missile engagement zone for the SA6s, it will initiate the cooperative blinking tactic. Every time the transmitters for the SA6s, the straight flushes, turn on, they will shift their center frequency by a certain amount. I've specified plus or minus 12.5 megahertz just for illustration purposes. And they'll do so every 18 seconds. They'll alternate transmitting every 18 seconds. And again, that's for illustration purposes to allow me time to tune in to the center frequency for one of the sites. And when that site shuts off and turns back on, we'll be able to see the shift in the center frequency. Now, the Kolchuga will continue to listen for that incident RF energy, and when it judges that the threat is inside the missile, or in the heart of the envelope for those missiles, it will turn over control, autonomous control, to the C3 vehicles at each of those SAM sites, and those sites will be then authorized to engage independently, turn on the target tracking radars, and try and shoot down the threat. So let's get into it. The Codescript editor itself is available inside the MACE plugin manager, and the plugin manager is in MACE System Settings, Plugins tab. Now, the plugin manager gives the user the ability to manage their plugins at runtime, so you can unload a plugin or load a plugin from the plugin manager. You can get summary information about each plugin, descriptions, where to find buttons in the MACE UI. And the code scripts, in addition to managing your plugins, the plugin manager also manages code scripts. And code scripts are cataloged. There are normal code scripts that just either add a button to the MACE UI or execute immediately on execution. And there are code script actions and triggers that allow the MACE user to extend the default actions and triggers that are available in the MACE scripting editor. What we're concerned about today is emulating that tactic, and that's accomplished via this Blink 6 script that I just loaded into my editor here. And you'll notice, in addition to syntax highlighting, I can get IntelliSense information for all of the API calls that are leveraged in this script. And I also have access to the API documentation for the MACE API. So I can see class diagrams, full documentation for what each of my methods does directly inside the Codescript editor itself. Now, in a code script, there's lots of ways to accomplish your task. But the way we're going to accomplish our goals today is we're going to leverage the MACE event handlers that are already exposed in the API. And there are really two primary MACE events that we're concerned about. One is the IEW environment cycle complete event handler, and there is a IF signal data stream device receiver IF signal data stream event handler. Now, in the initialization for this code script, I am doing the subscription for the IEW environment complete. What that does is when the MACE signal generation engine has completed its calculations for the entire RF environment, it will call the event handler that I have specified here. And in this code script, what that does is it looks for two straight flush radars in the Kolchuga, maps them appropriately to the local object references that I have set in the code script to allow me to then control those devices. And once the receiver's found, I can specifically subscribe to the IF signal data stream for that receiver. So this will be specific to the Colchuga, and what this event handler will do is when that device receives RF energy, it will try and categorize the signals in the manner that I lined out previously. So it's going to look for a blue aircraft specifically. It's going to make some decisions based on ranges as to whether to turn the tactic on or off, and whether or not to transition those SA6s from manual to autonomous. So they'll begin as manual. The script itself will be doing all of the radar control, and when they're in the heart of the envelope, they will transition to auto and be cleared to engage. All right, so that's a rough overview of what the code script is going to accomplish. Let's go over some of our displays. My threat today is going to be an F/A-18E Super Hornet, call sign Victory 1-1. It will be transiting from west to east along these predefined waypoints. Attached to Victory 1-1, I have an ALR-20 pan scope, just so we can characterize some of the incident signals as they're coming in, and an RWR display. In addition to that, I have armor showing me terrain, and it'll show me the physical environment, the 3D physical environment, as well as the RF environment as this mission executes. The messages window will display logged messages from the code script. Now, as these sites are radiating, we're going to take a look at what situational awareness the other component platforms of the site have as those radars turn on and off. And what we'll see is, because they're linked by a tactical data link, that all of the sites, all of the platforms within this emulated SAM site will have situational awareness to the threat as it's incoming. Okay, so let's go ahead and play our first we need to compile our code script, so we'll build it and run it, and we can see that it compiled successfully and initialized successfully. My icon changed to a gear to show that the initialization process is complete, and I get a logged event on initialization from inside the code script, showing me that that code script has been initialized and all the relevant event listeners have been attached. So let's go ahead and play. When I click play, I can see my radars have been assigned and my receiver's been assigned, and as this threat transits in, we'll see all of those behaviors, those predefined behaviors kick in. So there we go. He's tripped that tripwire, and the sites have begun transmitting. So I'm going to go ahead and freeze Victory 1-1's movement, so we can take a look at those incident signals. So currently, radar 1 is the radar in the south. He's transmitting on 4610. Radar 2 just turned on at 4592 megahertz. So I'm going to go ahead and try and get relatively close to that signal. There we go. There we go. I can see that that center frequency is roughly at 4592. That transmitter's turned off. The transmitter in the south is now turned on. 18 seconds will elapse and transmitter 1 will come back on, and when it does, what we should see is that our center frequency has shifted. There he is, he's back on, and sure enough, we can see that it's now shifted here. And we'll go ahead and center up on that. It's roughly 4602. We'll make sure that that's what we see when it sweeps back through, and it is. Okay, so let's take a look at what situational awareness each of these sites have. I'm going to go ahead and pull up the Colchuga. We can see that the Colchuga is receiving situational awareness information, higher confidence situational awareness information than it would otherwise receive as a passive receiver, and it's doing that via the tactical data link. So it's receiving the targeting information from the SA6 radar In this case, we'll go ahead and select that radar. It's the radar in the north. And we can see that that radar has set that as a priority target. So this radar is like, I see a threat, it's a priority threat, and it's informing all the other sites inside inside that network of that threat. Okay, so what I'm going to go ahead and do is unfreeze the F-18 and allow him to continue to move in towards the SAM site. Here we can see the sites continue to blink. I have it just arbitrarily set to roughly 10 nautical miles to transition control to autonomous for those sites. And we'll see that happen here in the messages window when that tripwire is met. We'll also see indications on our RWR display. We'll get those critical spikes, and we should see our aircraft react as well. Roughly waypoint 2 is where that'll happen. There we go. Transition to auto control. Both TTRs come on. Aircraft immediately defends and dispenses chaff, and the SAM sites launch their weapons. Okay, so this has been an overview of extending MACE default artificial intelligence using the embedded CodeScript editor. I hope you enjoyed it, and we'll see you next time.